This is the official IEB 2021 final Matric Maths Paper 1 exam, and I'm going to be walking you through each of these questions in separate videos, and today's video is of course going to question 1, which is out of 20 marks. Okay, so this first question says, use the formula, which is the quadratic formula, to solve for x correct to 2 decimal places if we have this equation. Okay, so the first step is to write this equation in standard form, and the way to do so is to bring all your constants and variables to one side of your equal sign such that the other side of your equal sign is just a 0. So we have 3x squared minus 5x minus 3, because we take this 3 across, we subtract it from both sides, is equal to 0. Now, where does this equation come from? So the quadratic equation comes from the standard form ax squared plus bx plus c equal to 0. So as you can see, we've brought these into the same form, the standard form, and we can then identify that 3 is equal to a, negative 5 is equal to b, and negative 3 is equal to c. Okay, so all that's left to do is to substitute these into this equation. So let's go ahead and do that. So x then is equal to minus b, and for b, we're going to be substituting in minus 5. And that's going to be plus minus the square root of b squared. Now, b is minus 5, so we're going to be squaring that negative, and then it's minus 4 times by a is 3, and that times by c, which is minus 3. And it's the square root of everything there. Okay, and all of this is over 2 times by a. And a is equal to 3. Okay, so what you should go ahead now and do is substitute these values into, or type them into your calculator, and you'll get an answer for the plus sign, and then you can go back and delete the plus, make it a negative, and then you'll obviously get another value. And your two values that you should get is x is equal to 2.14 or x is equal to negative 0.47. And that's this question solved. Okay, so moving on to the second part of question A, it asks us to solve for x if 3x squared minus 5x minus 3 is greater than 0. Okay, so we know that these are the two solutions for this quadratic equation. So that's very important, because that means we can factorize this into something that looks like this. X minus 2.14 and x minus the second root, so a minus times a minus is a positive 0.47. Okay, so what this allows us to do by writing it in this form is it just makes it clearer, is because we know that this graph has an intercept at negative 0.47 and 2.14. We also know that it's a minimum value parabola because the coefficient of x squared is positive. So it must then look something like this. And we are asked, where is this parabola greater than 0? So, of course, then the question to ask is, where is 0? Well, 0 is the x-axis. This is the y equal to 0 line, or the x-axis. And we are asked, where are all of these, what x values give us y values that are greater than 0? And of course, if that x value there is 2.14, and this x value over here is negative 0.47, then in order to get y values that are greater than 0, we need to be to the right side of 2.14 and to the left side of negative 0.47. Okay, so then we can say x must be less than negative 0.47, or x must be greater than 2.14. And now, of course, you must notice that these are strict inequality signs. In other words, we haven't included the equal to sign, and we haven't done so because this here wanted to be strictly greater than 0, this initial inequality. So we can't lie on that exact point. We have to strictly be above y equal to 0. And in order to be above y equal to 0, we cannot be on y equal to 0, which means we can't include 2.14 or negative 0.47. And that completes the solution to part 2 of question A. Okay, so moving on to question B. Solve for x and y if 2y minus 24x is equal to 0 and y is equal to x squared x squared plus 5x. Okay, so what we do here is we can substitute in this for y. Since y is equal to this, we can just take this and put it in there in place of y. And the beauty of that is that we are then expressing this equation purely in terms of x. And we know how to solve equations of one variable. So we go ahead and do that. So then for y, we substitute in x squared plus 5x. and then of course we have minus 24x, and that's equal to 0. And you can see where this came from. This equation is this equation, except now in place of y, I have x squared plus 5x. Okay, so now I simplify this, bring it in standard form. I distribute this 2. I get 2x squared plus 10x minus 24x is equal to 0. Well, 10x minus 24x is minus 14x. Now we have a simple quadratic equation to solve, and to solve this, we're going to be taking out a factor from each of these terms of 2x. So doing so, we get 2x into x minus 7 is equal to 0. And you can see that those two left-hand sides are equivalent, since if we distribute this 2x back, we get 2x squared, and this 2x into the negative 7, we get negative 14x. Okay, so this then tells us that our solutions for x are x is equal to 0 or x is equal to 7. But here's the crucial mistake that a lot of people make. They leave the solution there, and that's obviously incorrect because it says solve for x and y, and we've only solved for x. So we now need to find the corresponding values of y for that value of x and for that value of x. So in order to do so, we can simply substitute in this value of x into one of these equations. Okay, so let's substitute x into this equation, x equal to 0. If we do so, we see that y is then equal to 0 squared plus 5 times by 0, which is, of course, y is equal to 0. And now, for x equal to 7, if we substitute that in here, we get y is equal to 7 squared plus 5 times by 7. Now, 7 squared is 49, and 5 times by 7 is 35. And then if you solve that, you get y is equal to 84. And then we have solved this question. Now, question C, solve for x if. Now we've been given this equation. Now, the first thing you should note is that there is a surd or a square root in this equation. So the first thing you need to do is to isolate it, put it on one side and take everything else to the other side. And I'll show you why. So first, let's go ahead and do that. We have x plus 7 is equal to x plus 1. But now we need to subtract 6 from both sides so that we can get rid of the 6 on the left-hand side. So x plus 1 minus 6. But plus 1 minus 6 is just minus 5. Now, the trick now, which is why it was so useful to take the 6 across, is we can square both sides. And that eliminates that square root. So if we square both sides, then we get x plus 7 is equal to x squared. Now I'm simply expanding this. X squared minus 10x plus 25. Okay, now what we have to do is solve for x. Okay, so I have a quadratic equation and I need to bring it into standard form. So we have 0 on one side and we have x squared, and now we take this x across. So subtract x from that side and subtract x from that side. Now if we subtract x from negative 10x, we get negative 11x. Now if we subtract 7 from both the left-hand side and the right-hand side, we'll be subtracting 7 from 25 and we'll be left with positive 18. Now this is a factorable quadratic equation, and so if we factorize it, we get x minus 9 times by x minus 2 as our two terms. And you can obviously distribute that back to check that it indeed does give you that equation. So from this, we can tell then that x must be equal to 9 or x must be equal to 2. And here now is another crucial mistake. A lot of people leave their answer at this point, and unfortunately, you'd be wrong because of this part here where you are square rooting something and then squaring it again, and you just leave it as x plus 7. It technically should be, and you don't need to worry about this, it's just for your own interest, should be the absolute value of x plus 7. And because of that quirky little step there, and we just simply writing it as x plus 7, we have solutions that may not always be true. So we need to check them. And instead of course, solving this equation with an absolute value that you may not know how to work with, it's best to just go ahead and do it as I've done it, and now to be aware to check your solutions. So these solutions might not work. Maybe none of them will work, maybe both of them will work, but we have to find out. And in order to find out, we substitute it back into this initial equation. Okay, and we see if that equation holds true. And of course, the equation holds true if both the left-hand side and the right-hand side equal each other. If your left-hand side doesn't equal your right-hand side, you don't have a solution, and then you'll be crossing out one of the equal signs. Okay, so let's try x equal to 9. So we have 6 plus the square root of 9 plus 7 is equal to 9 plus 1. And okay, this is for x equal to 9. You can see how I got that. I just substituted 9 wherever I saw an x. Now, 9 plus 7 is equal to 16. So inside there, I can replace 9 plus 7 with 16. Well, the square root of 16 is indeed 4. So 6 plus 4 is 10, and 9 plus 1 is 10. So this equation holds true. So we can then say that that is indeed going to be one of our solutions. Now, we need to check for x is equal to 2. So now substituting 2 into that equation, we say 6 plus the square root of 2 plus 7 is equal to 2 plus 1. And you can obviously see there, I've replaced an x with a 2. Okay, so solving this, we get 6 plus the square root of 9 is equal to 2 plus 1, which is 3. And the square root of 9 is equal to 3. And then we have 6 plus 3 is equal to 9. And now we've come to something which is clearly false. 9 does not, in fact, equal to 3. And therefore, x equal to 2 is not a solution to that equation. Okay, so now we have solved this, and we know that x must then be equal to 9. Okay, so this is the last question of question 1, and it is a sequences and series question, more specifically a series question. Now, the first thing to do when you see a series question, of course, let's just read the question first. So, if the first 3 terms of a geometric series are 2 plus 6 plus 18 plus so on, so on, so on, then what is the value of n if the series is equal to 177,146? Well, first of all, let's identify what our common ratio is, since we know that it's a geometric series. Well, what did we have to multiply 2 by to get to 6? We had to multiply by 3. And what did we have to multiply 6 by to get to 18? Well, once again, we have to multiply by 3, hence why it's a common ratio. Okay, and our first term is equal to 2. So these are important numbers here then. 2, which is our first term, and our common ratio, which is 3. Now, why are these important? Because of our formula. Now, I recommend you write out the formula just in case you go ahead and make some substitution mistake. You obviously want to show your marker that you know what you're talking about. So, the sum of a geometric series with n terms is equal to a, which is this first term, into 1 minus r to the power of n, all over 1 minus r. And now, if you have learned an equation where you have this 1 and this r to the power of n switched around, and you have this 1 and this r switched around, that's perfectly fine. They'll both be correct. So what I'm saying is that this is also equal to a into r to the power of n minus 1 over r minus 1. And of course, you can see why these two are equal. If you were to multiply this equation by a negative in the numerator and a negative in the denominator, negative 1, what you're essentially doing is you're multiplying by 1. It doesn't change the value because you could simply cancel those out. But now, if you distribute this negative into here, you get negative Rn plus 1. And as you can see there, that makes sense, minus Rn plus 1. And in the denominator, we get minus R plus 1, which is the same as that. So, yes, it is, of course, fine to use either of these formulae. All right, so I'll go ahead and use this left-hand one. Now, I'm trying to solve for n, and I know this. So I'm going to substitute that in. I have 177,146 is equal to a, which is 2, into 1 minus, and now my r is my common ratio, which is 3 to the power of n, and this is all over 1 minus r, and r here is equal to 3, once again. Okay, so 1 minus 3 is equal to negative 2. But now I have a 2 in the numerator and denominator, so I can cancel them out. And then I can multiply this right-hand side and this left-hand side by negative 1 to get rid of this negative. So multiply it by negative 1, and then that becomes a negative. So let's rewrite this so it's not so messy and easier to think about. We have minus 177,146 is equal to 1 minus 3 to the n. But now, of course, we're distributing this negative into this bottom negative. So this remains as 1 minus 3 to the n. Okay, now what we have to do is solve for n. So we take this negative 3n across, and we get 3 to the n is equal to, now 1 plus this. So it's 1 plus 177,146, which is, of course, equal to 177,147. Okay, now all you have to do is solve for n. So the easiest way is to go to your calculator, and you type in n is equal to the log of 177,147 to the base 3. And these are simple log laws, not log laws, but these are simple notation for logarithms that you should know in order to convert an equation in exponential form to an equation in logarithmic form. So then you can type that into your calculator and you will get the answer of n equal to 11. So I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. I'm going to be following this video up with videos on question 2 to 12 for this paper, and also for paper 2, I'm going to be doing the exact same thing for 2021. Thank you.